you arrived.
Hmm.
My times and my location coordinates were all over the board. Like I had my sky set up for a different set of coordinates from my
Wow.
hand controller, and I think that may have messed me up. I seem to be consistently getting the objects in my 183 off on one side to the edge.
Hmm.
Now, it could be orthogonality as well. I looked that up today. I'm going to try just getting all the coordinates and times consistent and see if that makes a difference. If it doesn't make a difference, then it might be orthogonal. Off to the side.
So you're just using your mount, you're not using the ASIR?
No, I'm using the mount with Gemini and a laptop.
Hmm.
I'm definitely going to try the ASI Air sometime this week.
Okay.
I don't know if you caught what Ken just said, but Ken's just packed it in. So
What do you mean you packed it in?
his ASI Pro just packed it in.
It died?
It's not receiving the signals to the mount. It can't talk to the mount.
Oh, weird.
And I also lost power in two of the pins a couple of months ago. Sort of waiting on a power board to come. So I just packed it up and shipped it back today. They're shipping me out another one.
Yeah, I was saying to Ken he should just keep a spare boot card because the Pis routinely corrupt their SD cards.
Right.
So you should always have like a spare kind of boot, basically.
Yeah. I created a backup image of mine, but I don't have a spare boot. I'd have to actually buy one if it corrupted. But
yeah, that's good. I mean, make the image and then you can make an SD anytime you want.
From what I gather, if you don't make the boot and it does get corrupt, it's a nightmare trying to get another one out of ZWO.
I heard recently that they've got a download now. So they've got a link where you can actually construct the factory version of it.
Okay, well that's good. I thought it was a protection they had to for their copyright sort of thing, right? So
maybe I thought about that afterwards, but they may have coded something in to make sure it's their daughter board and their stuff. So
yeah, it would be not that hard to put a little crypto chip or something on their daughter board.
Yeah, exactly, because it's
there's these little super inexpensive crypto chips that you can use just for a unique identifier that you could put on the power board and make it so that that's essentially like a license and you can't do it without it.
Yeah, they've had signatures on chips forever. I mean, most chips have signatures on them.
Yeah.
But the thing with the ASI Air is that it does have that custom daughter board. You can't just go buy a Pi and do what it does.
Exactly.
So.
Yeah, that's kind of the whole point. Like even if they put the code just out on the internet, like you couldn't use it. You can't just go buy a Pi 4 and just make it work. So
now you can use something like Stellarmate. You can buy that and put it on a Pi, but then you're missing the you're missing the 12-volt distribution and the dew heater stuff.
Actually, that's a huge part of it for me. I just find it simplifies everything. Like having all my dew heaters and my camera powered out of the Pi or out of the ASIR, it's brilliant. Just
it's good. It's good. I may end up doing that on the Gemini mount, but I decided to just get a little Pegasus power box, and that's working really well for me.
Yeah. I'm enjoying the plate solving because before, just with the mount, it would go to pretty well if I really spent time doing lots of star alignments and stuff, but still can't beat just, getting that preview and saying, oh, I want to center it a little differently, and just touching the screen and say, center on this spot right
here. And all that from your bedroom, eh?
Exactly.
You're being spoiled.
I am totally spoiled. Yes, and if I'd have gotten into this hobby,
I feel self-righteous because I actually have to go out on the driveway and it's cold out there, so I feel better.
I'm down at Cattle Point.
Yeah, going driving somewhere and setting up, that's a lot of work. I respect people that go to that much work. My telescope's been sitting on my patio now for 3 days in a row, just hasn't moved. Just turn it on at night and just start imaging.
Ouch.
Does anybody in our club have a permanently set up telescope? Oh, Sid does.
Sid
No,
does, yeah.
I don't know.
Bill
Like an
Allman
actual-
does,
with
but
a-
he's
with a-
pretty well done with it. He's got a 12-inch Meade that he's selling along with his observatory if anybody wants one.
Who's that?
Bill Allman,
Oh,
older member of ours who was quite active in the old days.
Hmm.
Yeah, that era is over.
Now the
Be
other
quite a
great-
bargain if someone had some construction skills and was a dedicated amateur astronomer with a decent sized lot.
yeah,
bargain.
Bill's observatory is on stilts. So
oh, really?
Yeah, so he wants it disassembled and taken away.
Oh, I should talk to him. I have an acre and a half. I have room for things.
Yeah,
yeah,
well,
you
he has it attached to his house, sort of.
Oh, okay.
It's
I wouldn't want
isolated,
that.
but it's not.
Yeah.
But it's right adjacent.
it would likely need to be craned out, I think.
Oh, yeah, that's not.
Well, I think I would just take it apart.
You think so? Yeah, maybe.
Yeah, I mean the timbers alone are worth taking it apart for.
Is it a retractable roof, like one of those sideways sliding roofs? Or?
It's a dome,
It's a
Oh, it's
real
a
dome.
dome. A
It's a
real
dome.
dome. Wow.
A rotating dome.
Oh,
eight
man.
foot. I think it's an 8-foot dome, and a 12-inch Meade SCT in it.
Wow.
Which obviously is optional if you want that or
Mhm.
not.
Brock, you should just buy one of those Astro Havens. Those
Is
those
the
commercially
ones
made
that kind of
things.
fold open? And
Yeah,
Clamshells. Yeah, if
Yeah,
you
I
want to
don't-
have a look at one, you could have a look at
I don't have
Shawnigan
unlimited.
Lake.
I don't have unlimited budget. So. It was
Yeah,
a big
Shawnigan
stretch
Lake
for me to
School
buy what I had.
got a big one, a 12-footer.
Wow.
It's pretty impressive.
Although with
Well, it's just about time. Maybe we'll get started
Sure.
this evening. Welcome everyone to our latest Astro Cafe, and I'd like to welcome Brendon Roy. You may see him on your screen there, who is calling in from Thunder Bay this evening. So welcome to Victoria this evening. Brendon did attend the GA in 2014, as I recall, so he is not a stranger to these parts.
I'm not.
And maybe you just tell us a little bit about some of your, because you've got a national role, is that right?
I do. So how would I start at the beginning? So I've been a member of the society since we'll say the mid 1990s. I have spent the last 8 years as the president of the Thunder Bay Center, which from where I'm calling you tonight. And last June, I joined the group on the board of directors. So now I'm a director of the society, and I don't belong just to the Thunder Bay Center anymore. I belong to everybody of the society. So I'm hoping to kind of meet everyone by crashing their meetings across the country. So there's been a few late nights here as I go from the East Coast all the way to the West Coast, but it's been okay. It's been a pretty good time. If you guys have any questions for me, you're free to ask, but that's me in a nutshell, and I don't want to hold up the meeting too much.
What sort of astronomy do you like to do?
I'm a visual observer. I would like to do something a little more significant than just astrophotography. I kind of got a thing for asteroid occultations, but unfortunately the paths don't cross my locale very often, so I have to do a little bit more from that. I have an observatory in the backyard. I run a Meade LX200 14-inch for my primary scope, and I have an 8-inch Meade CST that is my kind of travel scope, and that's been with me since the beginning. I do a lot of outreach I do a lot of outreach. I travel to a lot of the parks and that, and show people the night sky. And then once they're done, I take over and do the deep sky observing as much as I can.
Great. Well, thank you for joining us tonight. And yeah, if you have any questions, please feel free to jump in. Tonight, our main event is Dorothy has a talk put together for us. So I don't know if you're ready, Dorothy. So you are here, but.
Well, I will find out if I'm ready, I guess, if I may share the screen.
Please go ahead.
Let's see, share screen down here, I think. I don't know what all these.
Yeah, and that has come up. There we are. We have something.
This isn't what I'm going after. I've got something else here. How do I get my screen?
One of the quirks in Zoom is that you can either choose to kind of show everything or individual items. So if this was individually chosen, you'll need to stop and start again with the thing you want. I guess if that helps.
You need to stop the share and then start a new one.
Yeah, start the thing you want to share.
Where do the problem is.
So up at the top, it should say stop share.
I've got the,
here, I'll stop this share and then you can start again. There we go. So
okay. Start again. Okay, well, first of all.
And when you go into that share screen, it should give you some options of what you're sharing.
Yeah, I remember from before, I didn't think I was going to get this problem. Okay. I've got share screen down at the bottom, which is what I.
Yeah, and then that should open a window that gives you some options of what you're going to share.
Select a window. Okay,
yeah.
So a screen.
So you want to share, if you share your screen, we'll see everything that's on your computer, so then you can control what's.
Well, that's what I see. Let's see. This is.
Okay, that's where we were. So can you open what you want to show us?
But I don't see anything. Okay, let me.
Can you see where to turn that off again?
How on earth do I get out of this?
It should be up at the top center. There should be a way to stop sharing.
Dorothy, move your cursor up to the top, towards the top of the screen, and then you'll see it.
Well, all I see is my screen right now. I've got some crazy thing going on. This is.
Okay, well, let me stop it again for you. There. Okay, so it's.
Okay, so I have what I have here is I see everybody's.
Yeah.
Faces. I have a view, I have a speaker view, gallery view, reverse video order, full screen. I have what I want, I think.
Yeah, you just need to share it so we can see it, but we got to find the right one.
But I have only one choice for sharing.
Oh.
Which is down at the bottom.
Yeah, but when you open that and you get that select a window, how many choices do you have there?
Screen 1, sky view, whiteboard, phone, iPad. Screen 2, which shows a picture of my desktop, which is what I've pushed before.
I try the other screen, Dorothy.
Do you have a screen 1 then, or just?
Yeah, do the first one. Yeah. Choose the first one.
Oh, screen 1. Okay, that's.
Just choose that one, and share it.
Okay.
There you go.
I thought I was sharing all of you.
Yeah. Yeah.
Okay.
So then you should be able to open what you want to show us.
So I'm in business now.
Yeah. Great. Thanks.
So let's come here. Sorry about that. Live and learn, except I don't know how to learn. Okay, so Just if you wouldn't bear with me for a moment, because I've got to, there we go. Hide thumbnail videos. I like to look at your faces, but they were covering the screen. Okay, so this is fairly complex, but I'll try to go through it as many parts to it. Really exciting discovery, a galactic scale gas wave in the solar neighborhood, and it's been named by the discoverers the Radcliffe wave. What I'd like to do is start with just briefly the big picture, then talk about the research team and the discovery with not a lot of technical details, because the technical details are, well, they're either the raw data or math and computer stuff beyond me. But, and then consider the history of an astronomy behind the name, and end with some evolving views of our home, our Milky Way galaxy that comes from this discovery. So in 2019, NASA put forth what they called a new view of the Milky Way galaxy. Now, what's interesting was the thing that was interesting, and they pointed out, was this graphic that they used. You notice down at the bottom, R. Hunt, NASA, JPL, Caltech, 2017. So they had new data to add to the view of the structure of our home galaxy. But when they looked at old graphic that the NASA artist, be interesting to know how they work, the NASA artist has done, they noticed that actually these features were sort of hinted in there. The artist had pulled things or seen things that were more subtle in the data than the astronomers themselves had noticed before. And this is kind of a theme that we'll come back to, the art science interrelationship. They're really two views of one of reality, whatever that is. So now our galaxy has four arms rather than two major arms and two minor arms. The Scutum Centaurus arm has now been extended out to the outer arm, to the new arm, they call it, because the outer arm, which is an extension of the normal arm, which we're familiar with, which is, to see if I can get the cursor to show up here, but they goes from this end of the galaxy and winds around. And then in addition, there's a local arm. We're no longer on a spur, kind of a little something sticking out accidentally from some other arm, but we have a local arm of our own. It's at the moment classified as a partial arm between Sagittarius and the Perseus arms, Sagittarius arm and the Perseus arm. Probably an extension of the Perseus arm, but that's still being looked at. And so here we are, local arm up here, and the sun on the inner side of the local arm. So in 2020, this very exciting paper was published right in very early January. And this title I took is actually the title of the paper. So what is this? It's a 9,000 light year long ribbon of gas and dust. It's the longest structure of interacting nebulae known. It's called the backbone of the local arm, which sounds like a funny name because if you think about bones as being stiff, but of course they aren't always. It constitutes, well, I'll come back to more details, but 20% of the width and 40% of the length of the whole local arm. It undulates above and below the galactic plane. So it's really is a wave, not a straight, stiff structure, you might say. And it's about, looking straight out towards it, about 500 light years from the sun. So in 2013, Gaia, when the year Gaia was, late in the year Gaia was launched, ESA, European Space Agency, predicted that Gaia will give us some fundamental insights on the nature of our Milky Way galaxy. And of course, we know lots have come from this. So in 2020, the lead author on this new paper wrote, and it's in the paper, the flood of data from Gaia served as the perfect testbed for innovative new statistical methods that reveal the shape of local stellar nurseries and their connection to the Milky Way galactic structure. So I would like to just go over the research team. This is kind of a strange way to do things maybe, but it was fascinating to look at how this all came together. These are all the authors listed, and the ones that are in bold, Alves, Goodman, and Finkbeiner, are the leaders of the main groups. The others, there are a lot more interconnections between these people working in different labs, students, associates, and is indicated here. But if we look at the contributions that were made by these different complex groups of scientists, astronomers, physicists, computer scientists, Yo, I should go back here just and point out that the main author is home is at the University of Vienna, astrophysics, and was at the Radcliffe Institute as a fellow. And the other main authors are at institutes in North America. So Alves group has contributed a deep expertise on stars and star formation. He's a real expert on Gaia data, apparently. Goodman developed a 3D visualization and analytical framework called GLUE, I like that allowed the wave to be seen, explored, and quantitatively described. There interactive videos that one can follow on this. And Finkbeiner group developed and has been developing a statistical framework needed to infer the 3D distribution in the dust clouds. But this was really interesting, I thought, and gives some idea of the depth of this complex line of analysis that led to this discovery. Catherine Zucker was a graduate student in Alyssa Goodman's lab. And it was her doctoral work that really set the stage, provided the basic starting point for this latest study. It's not doesn't sound like bedtime reading. It's not a very exciting title or a large catalog of accurate distances to local molecular clouds, the Gaia Data Release 2 edition. Just about all the authors that were listed on the other paper were on this paper. So question is, how do you study molecular clouds from Gaia data? This from December 2020 picture from ESA is what 101.8 billion looks like, the total density of stars observed by Gaia. So at first glance, this looks like Milky Way with gas clouds, bright center line, but all the light, all that is from single points, star points. It takes a minute, at least took me a minute to really appreciate just what that is. And those are Gaia data. So those are all stars that Gaia has provided all the exact position in 3D, luminosities, all the various features which Gaia of stars that Gaia is recording. So what you get to molecular clouds by realizing that gas clouds absorb more blue light than red. So stars behind the clouds appear dimmer and redder than they would otherwise, but we know that. But you had to, and do this study, it had to be star by star within a chosen area or volume of sky that these telescopes have mapped. So was combining Gaia data and Planck data on micrometer to infrared data that Planck has collected. Interestingly, actually, Planck was stopped operation in 2013, the year that Gaia was launched. But as most of you probably know, we keep hearing more information is being pulled from the data which Planck collected during its operation. So Zucker et al. Started by inferring the distance and extinction to the individual stars along sight lines towards local molecular clouds. So they'd chosen a line of known molecular clouds, Orion nebulae and others much smaller, many of them familiar at least to deep sky observers, but not all of them, of course. They modeled a per star distance extinction using the Planck data. This is where things get quite complicated. I had fun, but got lost. They modeled these distances as being caused by dust screen. And I repeated that, so I missed something there. But anyway, that's all right. They used these maps to then determine the average distances to dozens of molecular clouds. And this is the summary diagram from their paper. And as it indicates down here, there are other figures online from the paper as well, and interactive maps to look at. So this was the starting point for this finding the Radcliffe wave, getting these exact distances to star clouds, which had already been identified. So these are denser regions, and getting their shapes. They are three-dimensional shape. We not just their mean distance, which is basically what we look up and find on tables, but to get their sort of three-dimensional structure, what part is thicker, what part is denser, I should say, what is deeper from our line of sight. So what Alves and group did was to look for structure in this map of interstellar clouds, was looking within 7,000 light years from the sun. So they visualized 2 × 10⁹ cubic light years of space. Kind of blows the mind, I find. They've found this gas wave in the solar neighborhood that's 20% the width and 40% the length of the local arm. So really an important fraction of the local arm's mass and cloud complexes, but they make it very clear that the local arm is much more dispersed and includes complexes that are not part of this gas wave. So it's distinct structure within the local arm. Its local arm is structured and more complex than previously thought, but it's consistent with something that has been surmised, that spiral arms are composed of quasi-linear structures of some size. So we named this structure the Radcliffe Wave in honor of the early 20th century female astronomers from Radcliffe College and the interdisciplinary spirit of the current Radcliffe Institute, which contributed to this discovery. That's quoting I think the last sentence of the paper. So here it is, the Radcliffe Wave, this humongous gas cloud close by. Undulating up and down across the local arm and away from the center of the galaxy. There, this is the sun, of course. So what is Radcliffe in history in as terms of Radcliffe's role in the history of astronomy and astrophysics? Radcliffe Institute was formed in 1999, but it actually has a very deep ancestry back into the 19th century. It's started as with the name of X. No name had been given to it. It came about after several years of very careful planning by the Society for the Collegiate Instruction of Women at Harvard. The president of the society and of X, which became in '82, got a real name when it was incorporated as the Harvard Annex, with Carrie Agassi as president. They quickly acquired property, gym. To be incorporated, of course, they needed a budget and a plan as a business, really. And started having graduate students and became Radcliffe College in 1894. Radcliffe, the name Radcliffe goes back to Anne Radcliffe in the 17th century, who lived in Boston, and a few years after Harvard University was started to educate the young men of the colony of Massachusetts, Anne Radcliffe made a large endowment to the university to support the stipends, to fellowships for students. I'm sure she would have been delighted to know that women would have been eventually been allowed university or college education, but at the time, of course, girls never went past high school if they even made it that far. Now, at this point, I should say a little bit more about what was involved here, because it took some doing to persuade the Harvard administration president to even allow this to be set up. But already, as indicated in the first year, the society had found 38 Harvard faculty who had volunteered to teach in separate courses. This is not coeducational, separate courses, women. And in fact, in this first year, 27 girls passed the entrance exam, the same that all boys did, and started their studies towards a bachelor's degree. It was in order to get this through and right through to the incorporation of Radcliffe College in 1894, it was definitely made clear by the society, by President Elizabeth Cary Agassiz, who apparently was a magnificent, tremendous diplomat. It's too bad we don't have more people like her here. They made the point that there was no intention ever to have coeducational courses. It would always be separate. And the Harvard side agreed that, yes, they would get identical education to the boys, have to pass all the exams, do everything exactly, but they would not get a Harvard degree or a Radcliffe degree. They would get a certificate of a Harvard degree. You know, if A equals B and B equals A, why not call them both A or both B? It's kind of ridiculous, but that's the way it was set up, and that's the way Radcliffe came into being. Interestingly, I think, and it's important what's coming later, is that this was only a little later than what was happening in England, where Cambridge University's College for Women, Newnham College, was set up in 1871, and the Cambridge University certificate was given to the girl graduates. In that case, however, they actually had a harder time in the first years and for some time after that, because the courses were not separate. They were coeducational. Of course, there were very few of them. So the girls' Newnham College was on the other side of the Cam River than the university. Had to bike across through the town, being jeered at by locals, and there were very few in these lecture courses, and boys clapped and hooted as the girls came in to listen to the lectures. Not exactly a very friendly, but many of them did, of course. Okay, so getting back to Radcliffe, in 1902, the first Radcliffe PhD, I'm not sure the field was, and then a lot of things happened, but after the Second World War, the two colleges agreed for financial and other reasons, space reasons, to have co-educational courses, but the colleges remained separate. So there were separate admissions, separate budgets. The Radcliffe's infrastructure, the dormitories, library, so on, had grown considerably. And of course, also endowments there were for in both colleges were growing to support scholarships for students. 1956, the first woman full professor to be appointed through a regular faculty promotion. This was big news, and I was in high school, and just about to start in high school, and I wasn't paying much attention to what was in the local papers or the major papers, but it was big news. And then finally in '69, Radcliffe and Harvard colleges merged. This was really difficult. All kinds of business and legal decisions had to be made, keeping the endowments and the support and all the different libraries and facilities of the two colleges available and working, but under one management. The big change was that enrollment went from 1 woman to 4 men to 1 to 1. So until that, it was 400 Radcliffe students to, I think 400 to 12, must have been 1,200 if I have the numbers there, right? 1,200 Harvard students, which is about right. So yeah, as Miles just said, that was about right. We graduated early in the 60s. And so then in 99, the Radcliffe Institute was then formed. The colleges had merged. Harvard College is the undergraduate college for all students, gender neutral. And the Radcliffe Institute was set up, the 13th, I think, of the special institutes and college schools within the Harvard University complex. So as a cross-disciplinary laboratory of ideas for transformative ideas across arts, humanities, and sciences. So let's look specifically at Radcliffe and the history of astronomy and astrophysics. First, just getting the main ones, there certainly are many others. Henrietta Leavitt graduated with a bachelor's degree in '92. As you know, she volunteered and became a major Harvard computer, observatory computer on Shapley. And in 1912, the Cepheid variable period and luminosity paper, relationship paper, was published, and we all know no more needs to be said about that. In 1895, Annie Jump Cannon enrolled in Radcliffe so she could take courses in the Harvard faculty. And she had an astronomy degree in physics and astronomy from Wellesley College in '84. And in 1901, the star classification paper was published. The "Oh, be a fine guy, kiss me later. Now, oh, be a fine girl," of course it was, when first what do you put together and expanded. Then in '23, the first graduate student in astronomy, Cecilia Payne, came with a certificate from Cambridge University, the Cavendish Laboratory, a degree in astrophysics. It's been said, really, and it's really the case, although it would have happened soon thereafter, but Cecilia brought astrophysics to across the Atlantic to North America. In 1925, she received her PhD in astronomy, Harvard's first, and her paper is on, which was published, stellar atmospheres. What's kind of amusing about this, and she was called, she has as a PhD in astronomy, but in fact, the Harvard Department of Astronomy didn't form until 1931. And it was actually, Shapley was very insistent that Cecilia's paper be published. And as you can see, it's the #1 of the Harvard Observatory monographs, because for years he'd been lobbying, as director of the observatory, been lobbying the university to set up an astronomy department. All the astronomy students, so astronomy was part of the physics department at the time. So let's look a bit more closely at what Cecilia actually did. It's pretty interesting. So she was at Cambridge from 1919 to 1923. Just to get there was a real struggle, but she was absolutely indomitable, brilliant, amazing analytical abilities and memory, not from a wealthy family, but set from the time she was 4 years old to be a scientist, really, to learn everything there was to know and to not accept givens, but wanted to know the facts. She must have been a kind of a horror with teachers in school, but she got a very well-rounded education and eventually managed to get into Cambridge University. Now, in 1919, an Indian student, as part of his PhD doctoral work, published a mathematical equation linking a star's temperature and pressure to its spectrum, basically providing a theoretical explanation for the OBAFGKM classification. Now, there were no observatories. Saha had no data to work from, but he knew the literature extremely well. He was a very good mathematician. This paper was very highly respected for the mathematics, but Cecilia wanted to test this hypothesis, and she knew the only way to do it was to go to the data, and the data were on the spectrographic plates at Harvard Observatory. So she set about putting together an irresistible application. I say irresistible to Shapley to go to the observatory. Her professors from the Cavendish laboratory, and she'd gone to the observatory, Cambridge Observatory, and insisted on starting actually sweeping the floors, but learning how to operate the telescope, and became very successful on public nights, explaining the sky, using the telescope and explaining the sky to visitors. Although she was a shy person, she was a very good teacher and very sharp thinker. So, but she knew, because she'd struggled, the family had not have a lot of money, and she knew that she needed to get financial support for herself so that she wouldn't have to be employed as a Harvard computer under Shapley's direction. So, and she managed to do this. This is where her classic training helped, because she got a fellowship, because she successfully, for that was advertised, because she successfully translated from ancient Greek, some early version of part of the Bible, which had been the test to get this fellowship. And she did it with no problem, because she'd had a good classical education in high school. So in 1925, she published this paper. This is the front cover of it, called "The Most Brilliant Thesis Ever Written in Astronomy." And basically what it showed was that stars are mostly made of hydrogen. So, I mean, that sounds straightforward. It was impeccable research work. All her readers agreed to that, it was. There's just one really big problem. Nobody believed it, because at this time, it was a certainty that all stars, all solar systems were like our solar system, that the spectra of the sun was being analyzed more and more deeply, that metals known from Earth are being found there. All stars must be like that. So, and it's impossible that hydrogen, the lightest of all elements, could be the most common element. It's kind of like struck me as flat Earth society, believing in the flat Earth versus a round Earth, that it was equivalent at this time. So she had to, in order to get it published, she had to, having laid it out absolutely clearly, the facts and the conclusions, put a little waffle sentence into the end that, although this is what the data show, it can't be right, and certainly must have irked her for the rest of her life, but it got published. And of course, shortly after that, minds of physicists, astrophysicists, astronomers were opening up. And she was, in fact, Russell, a few years later, using completely different data and approach, showed that clearly hydrogen is the major component, and he did sort of acknowledge, but it's never really made it. It seems to anyone who really looks at this to give the real credit where it's due. So it was Cecilia Payne-Kapashkin who became professor. She had married, meanwhile, a Romanian astronomer who became the first full professor at Harvard. So was an Radcliffe astronomy professor and made the news. I highly recommend this book, that if you're interested in knowing what life for students at Cambridge was like, and as well as what happened during the years of Cecilia Payne-Kapashkin's life, that this is an extremely well-written book and has a lot of interesting information and about astronomy as well as about societies. So Cecilia Payne-Kapashkin, now became the first woman full professor to be appointed to a regular faculty promotion. And this really did make a big, big news in North American, perhaps other newspapers. And I probably made special attention in my family. I wasn't paying a lot of attention to newspapers then, but my grandmother graduated from Radcliffe in, 1904 in classics, top of her class, as a matter of fact. My great aunt Dorothy, who was a great character and very athletic, very smart, and only graduated with a magna cum laude in history 3 years later in 1907. And so the fact that a Radcliffe graduate and a woman got appointed to the Harvard faculty was really big news. And of course, this was before the Radcliffe and Harvard colleges merged. So it was big news. And then in 2020, the Radcliffe wave adds to what Radcliffe has in various ways, Radcliffe people contributed to the development of astronomy and astrophysics. So it really seems an appropriate name for this extraordinary structure that has just been described. So from looking more closely at this, as you've already know, it was named in honor of both the early 20th century female astronomers from the college and the interdisciplinary spirit of the current Radcliffe Institute. Alves, the lead author, says, I had said when it came out, I came to Radcliffe to make a map of the galaxy, but I found many things that I didn't know I was looking for. Let's go on, if I may read a bit. When I first arrived, I attended an exhibition by Anna von Merten's work. She was talking about how the women computers had opened up the universe by measuring distances in the galaxy, a story astronomers know well. But she was telling this story with a quilt, which had these trails of stars. It brought me back to when I was 6, when I first saw those long exposure images of stars going over the horizon and leaving trails. I got to meet the artist and we started talking more and more. Looking together at scientific astronomical images I was working with, what blew my mind was how differently she looked at these images. She would talk about how the universe opens up and ask all these questions no one else would ask. I realized that if I started thinking like a visual artist, I could see much more in my own work. And that was a very important moment. You can find actually let's see, I think, is this on here? I don't, yeah. Maybe if you can't get the links from this, I could email to you if you're interested in looking at this. Talk of Anna van Mertens about measure, this title of her work, of these quilts. And in this talk, it's as much a technical exploration of the cosmos through unconventional media as it is artwork. Oh, here, yeah. Okay, this is the link that you should be able to get to this talk. If it doesn't work, if you're interested, let me know and I can email it separately. There's also a longer, so full-length lecture that João Alves gave at the end of his year fellowship at the Institute, which is excellent. It's fun, except that it's too long. It would have been fun just to simply turn it on and play that instead of my bumbling along with this. So let's recap a little bit here now. The Radcliffe wave, it's the largest gaseous structure connecting interstellar nurseries. What is its origin? Well, those are things which are being considered, studied, and modeled now. It's the outcome of some large-scale galactic process of gas accumulation. But is it from a shock wave front through the spiral arm? There are data and analyses, hypotheses that would suggest that, or from gravitational settling and cooling of gas onto the plane of the Milky Way. I can somehow visualize that more myself. How stable is this gas wave? Is it kind of transient, or we've just happened to be a lucky time where it's been discovered, or is it some more enduring, lasting structure that really does constitute a structural feature of the arm? The preliminary the way of looking at that, one way of looking at is to look at how the stars through the Radcliffe wave are moving, and going back to Gaia data. And that has just been starting. And so far, it indicates that it's a coherent unit that is staying together in the plane of the galaxy, oscillating or up and down. That I think I said earlier, if not, the sun actually moves through it. And every, 38,000 light years, So we would get different views of it if we could stay around long enough. There have been hints that similar structures exist in other galaxies, but they can't be examined as closely, or at least not by any means. So this is really very exciting in terms of understanding how large spiral galaxies come together. And just to close up, I'll point out that there are a lot of interactive displays and more material, as well as the original articles that one can go to. So I guess I'll wind this up here. And if there are any questions, comments, be happy to take them.
Dorothy, you show this extension of the arm. Is it expected that we would continue to maybe see something even beyond this?
Sorry, extension of the.
Well, that sort of a sinusoidal shock wave of that. You said it was somewhere between the Perseus and the Sagittarius arms. Are we expected?
Yeah, it's in the local arm.
Oh, in the local arm.
It is in. Sorry, yeah, it is in the local arm. Yeah.
But are we expected to maybe, with more detection, see something even beyond that, or maybe more?
You mean extending it?
Yeah.
Well, it's the volume of data. I can't find my cursor. But do you see my slide sorter here?
I do.
Yeah. Okay. In the lower right, this last slide, the volume of space in which the red wave is shown is not the whole volume of space which was analyzed. So where the ends of the wave were ends, there was not continuing denser gas there. Does that answer your question? I think. So
yeah, you're saying there's more data than is actually represented in that picture then?
Well, they had more data. They looked beyond those ends, and there were no no extensions of the gas cloud.
I see. Yeah, no, that answers my question.
Yeah, very good. Yeah, it's a good. Thank you. I mean, I somehow managed not to make that clear, and I really wish I could find my cursor, so I should do something with it.
It might be on your second screen.
On my second screen. Okay, let's try. I seem to be. Okay, I can go up, but why?
Well, the question I have.
Yeah, please, I
would there
can
be
listen
other,
while I search. Yeah.
Would there be other Radcliffe waves in other arms in our spiral galaxy instead of looking at other galaxies?
Yeah, that's to be expected. But this is the first structure of this size, and it is a structure. And so, as David just asked, and we looked in that last slide, it's a coherent structure in the local arm, and it's found and was easy to study because it is close. But yes, indeed, it's expected that there would be other structures like long bones in spiral arms. So hypotheses about how the arms in spiral galaxies form are definitely advanced by this discovery, because it's the first structure of this scale, anywhere nearly this scale, in an arm. And so trying to understand how it forms, yes, definitely looking for others, but it's assumed that there would be others in the Milky Way, which would be a lot easier to study than to surmise that might be what's happening in other galaxies. Yeah. Well, if there are no more, I'm going to have to ask. This is crazy. Absolutely crazy.
Would you like me to shut it down for you?
Yeah, you could, sure.
Okay, there we are. Well, thanks, Dorothy. So when you and Miles were there, so he was at Harvard and you were at Radcliffe.
That's right.
Mm.
We were in the ratio of 1 to 4. So I chose Miles as from 4 times the number.
Now they have co-ed dorms. When we were there, it was
Well, yeah.
nothing like that. They had,
Well, they were separate colleges, so.
yeah, well, we could have women in our room briefly at certain hours. I don't know. I don't remember.
Well, we could, yeah, you could come into the, and you did come into the
Yeah,
dorm I was
dinner,
in.
yeah, to dinner.
But,
dining.
yeah, there was talk then, in fact, there was starting to because of the house system, the real drawing card in the early 60s when we were there was that the Harvard house system had worked most magnificently. There were tutors, special events. Radcliffe's dormitories and houses just didn't have the facilities, and doubling up for tutors, and it made no sense. And the real drive from Radcliffe students' point of view is not just to get co-ed dorms, but to get a full house system that is really a whole community for arts, recreation, as well as the academics. Yeah, so yeah, it was interesting time.
YouTube has that presentation you referenced by.
Oh, thank you,
it's
Michael.
I just looked it up. It's on there.
Yeah, good. Yeah, it's worth it, and I hope that's the lecture by Alves and also the talk by Van Meritens, which is just really delightful.
Excellent. Well, thanks again.
Yeah.
Thanks,
Hey,
Dorothy. I didn't know anything about that at all. I'd not heard about that. So somewhere that got missed. So thank you a lot. Thanks a lot for bringing that to our attention.
Yeah, I think we've heard some of the names, but maybe not the linkage and how it
Yeah.
actually all happened at Harvard, basically at what is now Harvard.
Yeah, all through the observatory. I learned so much from this. I had many interruptions once after I started, sort of thinking this would be a fun subject, or the basic paper would be a fun subject for Astro Cafe, and it got bigger and bigger. And I didn't know a lot of the history and the details, and paring it down was hard. But the book, the biography of Cecilia Payne-Kapowskin is really a fun read, and Miles has read it. I think
Definitely worth reading. It's an excellent book.
Yeah. So it's give lots of things to think about when we're looking out at our local arm, remembering that the sun is on sort of the inner edge of the local arm.
Actually, I'm glad to hear this now that I'm in my 70s, because if I'd heard it in my teens, I would have realized how relatively stupid I was.
I don't know about that, Michael.
I would never have gone to university.
The only thing you need, and this is still true to get into Harvard, is to obviously have a modicum of ability, but to have some genuine driving interests and convincing the admissions committee that you really are dedicated to doing something. It's still a lottery because there's so many applicants and class size has to be kept. But we should wind this up because it's not appropriate subject, but I did for a number of years till stopping about half dozen years ago, interview local students. The admissions committee once tries to get interviews with all applicants around the world. And there's so many students because they're now applicants from around the world. And interviewing local applicants was, it was, well, mind-boggling, actually. Some of these, the not just the knowledge, but the drive, the determination, the ability that local students had. And these were not students necessarily from well-off families or the private schools. They were from public schools as well. It's just the determination to use what you have, abilities that you have, is probably the criterion that's most fundamental in the admissions committee is looking at. Okay.
Thanks for that.
Thanks very much, Dorothy. Fascinating.
You're welcome.
So as per usual, we have a few photographs from Edmonton. So Dave, are you available to do some narration as may be necessary? I think we've got 5 of them. Is that right? There's a link and 4 photos I've got. So hopefully that's right.
Yeah, I don't know how much narration I need to do. There was a lot of printed material that went with it.
And it's there. So let's fire this up and let's start the slideshow. Come on.
So the first one was from March 27th.
Oops,
and that,
sorry, yeah, that one.
yeah. So that one was Arnold Rivera with his fancy Schmidt camera thing. And they managed to have a lunar transit of the ISS that went right smack across the middle. So he compiled this from a whole bunch of video and then stacked the images in 5-frame increments. So if you're talking 5-frame increments and they're fairly short exposures, you can see how fast that sucker went across the moon. They actually found he found that that their timing was out a little bit the first go.
Second shot.
This is Anwar's. I think we showed this last week, his shot of the Leo trio, but what he did is he gathered some additional data and some old data from his Edge Hyperstar, Celestron Edge, and reprocessed it to show color. So I think that was,
yeah, last time I think it was the monochrome image.
It was monochrome, yeah. Now this was interesting because if you can read the thing, John Cliffe pointed out that the lady in the moon, or what we call the man in the moon, or what some call the rabbit in the moon, Abdur always thought of it as the T-Rex in the moon. And I thought his little sketch of where the T-Rex was would be very interesting to a couple of people who are lunophiles here.
So there's a new one for you, Randy. I'll try and get this web. So this is one of these stereoscopic vision, I think.
You can give it a go. This might be a little difficult for people. Yeah, it's a stereo image pair of the Veil Nebula. And if you have your eye at the right spot and you kind of do the cross-eyed thing, you'll see the stereo image in between the two others. It might be difficult to do, but look on the website, get that URL, and go have a look on your own computer. It's
I'll
quite
get that in the let's see if I can get it.
That is so cool. That works.
Yeah, it does work.
Yeah.
And this is from Tom Owen, another Edmonton fellow. There's a long explanation what he did here, but it's M101, and he's used a QSI camera, 3-minute lumens, 13 2-minute blues, and 14 2-minute greens, 15 2-minute reds. So he gets a color image from filtered single shots that run 3 minutes, and then in sort of a dozen or so in each color that he's used to put together. You see the star forming regions pop right out of that, don't they?
Mm-hmm. Great. Well, thank you for passing those on, Dave.
Yep.
Randy, I think you had a photo you wanted to show. Is that correct? An image?
I do.
And I'll see if I can get that link and just put it in the chat for the previous one.
Are we going to go? Let's see. I think you have the wrong side right now, right? Let's okay. go up here and I'm in the wrong screen. Silly me. Stop.
Okay, we were seeing it, but it wasn't in the slide, or it wasn't in the slideshow yet. It was.
We're going to do that again.
Yeah.
And we're going to do.
We're having PowerPoint gremlins tonight.
Oh, it always happens. There we go. So you've got it now?
I think so there, yeah. Now we're seeing this title page, I guess. Is that what you wanted?
Yeah, so this has been making a lot of noise in the press. Jukka-Pekka Metsavainio is this very accomplished astrophotographer in Finland, and he's north of the Arctic Circle. He's at 65 north, and I'm sure Chris can tell you there are issues with that. He can only image for half the year, and then I guess he spends the other half of the year processing, because it's just incredible. He's been working on this project doing very similar images. Like, he's been using the same filter bands and kind of ratios of exposures for 12 years. And he's now been able to put it together. There's his kit. So for his long wavelength, what do you call it? Focal length pictures. He's got this, the older pictures were a 12-inch Meade, and then he moved on to an 11-inch Celestron. And then he's got a 300 millimeter lens for the wider field. I love this. He's first of all, he's just pretty well glued the lens to his filter wheel. He actually talked about taking a grinder to the lens to get it to work. And then this is a file on a motor. So there's a little file moving up and down there, and that controls the focuser. So he's got an autofocus that he put together himself. Here's his mosaic, 125 by 22 degrees from M1 in Taurus, way over here on the left, all the way to Cygnus. So you see Cygnus there, the crane, and way over at the end, you get the dumbbell. And I'm just blown away at how busy this picture is. There it is in a bit more context. So you see the horns of Taurus here, and here's Cygnus going through Perseus and Cassiopeia. And I guess I'm really keen to hear from you experienced deep space viewers. Are you shocked at this the way I am? It just seems to me that there's so much more going on than I was thinking was even possible. What I'm going to do here, this is a higher resolution version, and we can actually go right in. So this is 7,000 pixels across. And if there's any parts that somebody wants to say, oh yeah, let's look at that, I'd be really pleased. Otherwise, I'm just going to slowly move it along for you. You can just enjoy it like that.
Can somebody give some scale? It's like people who are observers to know when you're, sort of the field of view, so to speak, for when you were, Randy, when you were showing that enlarged. No, I mean, like what are we looking at in
Yeah,
terms of
maybe if we
degrees?
maybe we just pick some common object, it would give us a sense for the field
Yeah,
of view.
that's because,
Well, that's what I'll do is I will go back to the presentation. I will go back to the presentation. And so, so there's Cygnus, okay?
okay, let's find those area around the Veil Nebula, say.
Yeah, so
Or you could look at the North American Nebula at
so
the head.
where would that be?
Well, it's the North American Nebula is just right below Deneb in Cygnus.
Okay, so around
There
here.
it is, right there. Yeah.
Okay, so now let's go to the photograph. Now that I know what you're talking about.
Oh, there it is. I see it.
Is it
Right
this?
there. Yeah, there's the pelican right beside it.
Okay, yeah,
And then you'll see Deneb there too, Dorothy.
yeah, yeah,
Okay,
okay.
so he
Yeah,
talks a bit
so-
about his processing, where he would take the larger scale and match up the stars with one of the high resolution pictures, and then in PixInsight get rid of all of the stars, match the levels, and then he would put the stars from the low res back in. And he does say that he's a visual artist. He does talk about the artistry of this. I guess I have a question of, is there a line between processing and cheating? I mean, I think that this is definitely on the processing side, but
Well,
I think if you did
processing
any
is-
more, then it would be towards what we would start calling cheating.
Cheating
Right.
is, I think most people would agree cheating is, when you make up data.
Yeah.
I don't think anyone can argue against processing data. I mean, obviously this guy has used false color images to reveal detail that you wouldn't see in those emission areas in particular, because they would be so red, you would have no clues as to what kind of structure was in there otherwise.
Right. So this is using very narrow band. He's in a light polluted city, and so he's using the what do you call it? The Hubble palette. So the hydrogen is green, the oxygen is blue, and the sulfur is red.
And so the light pollution would be not affecting him at all, because those are the narrow bands. And I would call this not cheating. I would call this an interpretation.
Yeah.
Yeah,
No, I mean,
I agree.
Yeah,
Well,
Dorothy.
it's just data processing. That's all it is.
And he's
I
very
did the same
transparent.
thing I did the same thing for years and years with satellite imagery, because we didn't have RGB to work with. We had narrowband as well.
Yeah.
That was 40 years ago. It's no
He's
different.
very transparent. He gives wonderful YouTubes about it. And then I just to go along with that stereo picture that you showed off, Dave. He did a book with who's the guitarist from Queen who got his doctorate?
May.
Brian May.
Brian May.
Brian May,
He did a
yeah.
book, and they did a delightful YouTube, which I watched just on my cell phone, because then your eyes are the right distance apart, because the whole YouTube was done stereo. But what they did is they took these various nebula, and using the astrophysical data about what's closer and what's further away. So the dark shadows were placed closer, and the stars that were dim were placed further back, and they had a structure to things like the Ring Nebula. And it's just fantastic. And so just holding onto your phone and looking through to infinity, you actually saw all the three dimensions. It's a very entertaining video.
It may be just coincidence, but in the long band picture, the original picture, there's this wave in the gaseous clouds, the nebulae, that is what Dorothy was talking about. So whether, I don't know if we're looking at the same thing, it's at Perseus arm, so we're looking toward Perseus through ours, through the local arm.
But it was discontinuous, wasn't it? I mean, they're contiguous or adjacent nebulae in perhaps in places a waving pattern, but not, at least it wasn't shown. Maybe it's there, but these data, these images could not show if it was really a continuous gas, denser, less dense, forming the gas clouds that we can see even visually, and ones that are the gas is much too dim, too disperse to be picked up by any amateur or even anything but Planck. And
I just thought it was a coincidence, presumably.
Yeah,
these.
Interesting though. Well, now I mean, I know, and I think maybe you're suggesting that others will now also, when you see undulating clouds, stars, I mean, to think about it. And actually, I didn't mention, but the researchers didn't make a lot out of it, but this galactic scale gas wave basically puts to rest any kind of sense of real explanation, functional explanation for what's been called Gould's belt. I think some of you know that parent circle of bright stars, which actually for centuries has been noticed. In the mid-19th century, astronomer Gould studied it and it got his name, but suggesting that somehow some one event caused a series of bright stars within fairly close to the sun, but they go northern and southern hemisphere, and only a small part of this is actually in the Radcliffe wave. So, but with the wave within one arm, you can't resist speculating that maybe that is part of a structure of the arm.
I think a major difference between what we're looking at with a fixed telescope here and what Dorothy's talking about is Dorothy's was a three-dimensional view, so knowing X, Y, Z, and not just the angles as visible from the Earth. It's also taking the distance into account, and so yeah, there it does look a bit wibbly here, but
it's a different wibble.
Distances don't make a linear feature.
Yeah.
If you were to actually color code them by distance, you would see that that's not anything that's nearly as well constrained as this Radcliffe wave is.
Yeah, that's right. One needs the depth from us. We're just looking kind of line of sight, what we can see without reference, that is visual astronomers, and without reference to real distance, and brightness does not indicate real distance.
Well, one of the interesting things, for taking the photographs from that particular location that far north is that you get a much more limited amount of sky to see. So he gets very familiar with the area of sky that he's dealing with, because that's 15 degrees north of, more than 15 degrees north of here. So there's 15 degrees less of the south. Yeah. If you think of it. So
is he going to be able to extend past that 125 degree swath?
Possibly not. He could probably go, he could go towards Polaris, but then there's no Milky Way up that way.
I think he needs to go to Costa Rica for the next 12 years.
Go on the other side.
Yeah. He does show a picture of the snow on his dome. So
Yeah.
it's one of the hazards of working up
In
there.
June, yes.
Yeah, that would be that would be a cold part of the world, I would think. That far north, because he's
Can you
almost on the
take-
Arctic Circle then.
A lot of dedication.
Is it dark enough during the day, Chris, to keep photographing 24 hours?
You'd in the middle of winter, you would that far north, you would still get some light, but it would be fairly limited. Probably where I lived was at 60. I'm most familiar with the last place I lived was 64 degrees north, and we had the sun up for about 4 hours in December.
But the narrow
then
band that he's
twilight.
using would help a little bit.
Yeah. So
Yeah.
yes, you could do you would have quite a long observing day. Is the short answer. Yeah. So does anybody else have anything for us this evening? David or Jim, I think we have a SIG group this week, right? Special interest group.
Yeah, I think just a quick update on the SIGs. Yeah, I think Jim just sent out a notice for this Thursday for the makers group, so that's great. Maybe John can report back about the Astro, and I'll report on the beginners and the EAA group. John, do you have anything to say about the Astrophoto group?
I think we've lost John.
Oh, okay. Anyways, I can talk about the EAA group. We've been meeting for extra meetings just to be prepared for the use of some of the EAA sessions during the virtual star parties this coming summer. So we've been going through a few growing pains, but I think we've got some good results. Well, at least from other people, maybe not for me, but we're getting. I'm actually getting used to my new go-to mount. So I haven't kind of ironed out all the bugs yet, but I know that Brock's been doing some pretty good work, and so is Dave Payne, and Ken's been doing some work as well. So we've all been really busy, so that's good, and taking advantage of the recent clear nights. The beginners group, we had a good virtual telescope walk. I don't know if people still remember what a virtual telescope walk is. That seems so long ago. Or a real telescope walk, I should say. So we had a virtual one instead. So we kind of just showed our scopes and talked a little bit about them. So that was a lot of fun. Yeah, so I think they're going well. I think the Astrophoto group is probably going well as well. Yeah, I don't know if anybody has any questions about the SIGs, but we're making them quite active, or trying to make them active.
When did the makers email go out? I haven't seen one.
It just came out today.
I sent that out this afternoon on the regular RASC list. Now, I'm not too sure if I should admit this, being a maker group, but I haven't quite managed to get the email list that Chris so kindly made up for me working yet. However, I'm going to be hopefully getting that going. But I did send a note out on the regular list. So this Friday, if we can get together, it's just going to be again a round table.
It's a Thursday, isn't it, Jim?
I beg your pardon?
It's a Thursday, isn't it?
Thursday, yes.
Yeah, Thursday, yeah.
And so it will just be a round table of projects that people are working on. And I did put out a suggestion about electronics and possibly homemade optics. I've got a fairly good bit of experience terrorizing the people in the plumbing department at Home Depot looking for parts that I can make into telescope tubes. So I can talk a little bit about that. And if anybody else has any projects that they have that they want to talk about or ask questions for anybody.
Yeah, and I guess we could also continue building on our resource list. The last time the makers group got together, we talked about where we sourced a lot of our little parts and stuff.
Yeah.
So
So Brock, if you don't see that, it went out on the RASC Vic list. I don't know if you're on that one.
Okay, I don't know.
So I'll forward that to you.
Okay.
And then if you want to be added to the RASC Vic list, I can do that for you as well. That's
Sure.
That one's more of a discussion group than Sky News. Sky News is we try to restrict who can send to that because that goes to everybody, and we don't really want to be blasting You know, we have quite a few members who we don't see too often, so we don't want to overload them with emails.
Yeah.
So we can get you on that list. I'll just make a note of that.
So Chris, just one last comment. This is actually for next week. There is a occultation of a bright star coming up on the 23rd, around 11 o'clock. So we're going to talk a little bit about how we can observe that next week, hopefully, and maybe doing some timings if we want to try that as well. It's kind of like a precursor to future occultations as well. It's kind of like a starter occultation. So it's something that's going to be really easy to do. And if we want to delve deeper into it, we'll be able to do that as well.
Right. Great. Yeah. So so let's we'll pick that up again next Monday. Then that'll be great.
Where is it, David?
It's New Virginus. It's about 11 o'clock on the Friday night.
April the 23rd.
April the 23rd.
What's the star date or number?
Oh, it's a New Virginus. I don't remember what the actual star number is. But if you just go into a planetarium program and put yourself just before 11 o'clock on April 23rd, look for the moon, and then you'll see this really bright star, and it'll go right into the dark limb.
Oh, neat.
Yeah, it's a not to miss thing. Definitely do it.
Well, yeah, I was going to ask about some unique features up there, because I was looking at, I think, Skywatch or something, and they mentioned there was a supernova near Cassiopeia.
Yeah.
Has anyone seen that?
Some of us have imaged that. I know Brock has imaged it. I imaged it with my tracker, and I didn't know what I was doing, so I did some plate solving and found it.
So it's easy to spot.
Well, yeah, if you've imaged it. I couldn't see it visually myself.
Okay, so it's too low a magnitude or too big a magnitude to see in the scope?
Yeah.
It's going to come closer eventually.
Yeah. And there was okay. And any comments up there to spot?
Yeah, there's Atlas 3, I think, that's out there, but it's still
there are a few. I don't know if there's any visual ones. It has to be pretty bright to be a visual one.
Yeah. Okay. Well, I'll look for the New Virginus, or is
New Virginus, right? Yeah. Just the other thing to do, we'll talk more about it next week, but if you go to the IOTA Lunar Occultation site and look for bright star occultations, you'll see that one there.
Chris?
Yeah.
Is
Chris or that Chris?
Sorry, if they're finished there. I just know that Brendon is going to be trying to get to the center of the June 10th annular eclipse from Thunder Bay. And Brendon, do you want to just talk a tiny little bit about what were your plans for that?
Oh, you're muted.
Mute. Mute.
Brendon, you're muted?
Yeah, he's muted. He's still talking. Oh dear.
Send them.
I'll send him the ask to unmute there and see if that.
Yeah, just a minute. See if we can find him.
There we are. I think we got you now.
Oh, there he is.
Okay. Sorry, we went to a different window. So yeah, I was just looking to see if I could see that occultation you guys are talking about. So for the June 10th, Thunder Bay is right off the center line. So we only have a couple hours drive to get to the center line. So I'm still considering my options, considering I don't know what the COVID protocols are going to look like come between now and then. There's only 2 major highways here to get there, basically. So if there's issues, I may not be able to get to the center. And then there's the cell phone issue, or basically internet access. And there's a lot of empty areas where I may not have access to any cell phone coverage, so I won't be able to broadcast. So I have to consider all those options before I head out. but I do intend to go. Like, I mean, I intend to try to get to the center line somewhere along the path. I know the northern highways well enough that I can find a spot that's set up, so I'm not too worried about that. It's just between the access and COVID stuff sort of throwing me at this point.
Well, there's not going to be very many people that are going to be on that center line. It's in a pretty remote place, so
it definitely is.
Luckier
it's
than
gonna
most.
be me and mosquitoes basically, but
Yeah.
you never know. So I mean, I would like to broadcast it if I could, but that's still kind of up in the air right now. I don't have a solid plan other than getting up real early and just headed out to the best spot that I pick between now and then. I know I have a couple people coming in from different provinces that are part of the center that want to go take a look. So I'll probably be in a small caravan early that morning.
Right. Well, I mean, as you know, we are trying to tell people not to go, miles and miles and miles and, come in from everywhere to go into some of the remote communities. But you live up there, so there you go.
There's lots of places you don't have to so people coming up here don't have to go into community. You can be smart about it too and still see it. But you don't have to go into these communities. And I mean, a lot of them are off the main highway anyways. So I'm picking a login road that I'm somewhat familiar with, and that's probably where I'm going to set up once I find, an open area that's been cleared and over the lake. Away I go.
Well, we hope you can get some pictures anyway for us, some images maybe on a camera and send them out if you can't stream it. So.
Well, I'll have I have my 8-inch Schmidt Castle Green. I have, the focal reducer and a Meade, or a Valancam universe that's going to be set up. So I'm sure I can accomplish something. And I also have a little ETX. And if you don't mind me sharing a screenshot with you.
Please go ahead.
See if I can show you guys this. Give me a second. Get my computer here to work as fast as I want it to.
Well, the signal's coming a long way.
That's fair. Okay. So if you guys can all see this, this is the Mercury transit.
We don't have it.
Can you see the screen?
I see it. I see it.
Yeah, I can see it.
Oh,
so Mercury. So definitely not polar lined. It was cloudy to well after first contact. So I never did get the opportunity to polar align. The sun came up through the clouds in November. Lake Superior is still open, and because it's so cold, the air mass produces a pretty heavy fog. So it took a while for the sun to clear that. I didn't get polar aligned, but that's something I kind of expected to be able to do come with the Annular eclipse, and that was without the focal reducer. I should be able to get the full scope of the sun with the focal reducer on in the universe. So I'm hoping to be able to broadcast something that's decent and not embarrass myself too much.
Thanks, Brendon. We'll be looking forward to it.
Yeah, Brendon, I
close to it. So
Brendon, I put the website for the IOTA site in the chat. It may not be visible from your area. There's a very narrow band for this.
So yes, I will be traveling. So I'm headed towards Geraldton, and I will get towards the center line. So I do have about a 3-hour drive ahead of me that morning. But I'll find a spot.
Thanks, Brendon.
Yeah.
It'll be in the rain, I'm sure.
Any final comments?
Chris, I have the occultation that's coming up for this for the 23rd lined up on a planetarium program here. If anybody would like to see it.
Yeah, and also in the chat, there's the actual site with the timings on it as well.
Yes.
Yes. thanks for that, Dave.
Yeah, thank you for that. I will bring that up.
Is that firing up, Jim, or did it not?
Okay, I can bring that up. Hang on.
Yeah, you might as well. As you've got it there for us, we'll just
I have it here. There we are. No, I thought I had it.
It's just take you a moment to launch there, and you're not so far away. So come on.
I'm working at it. I'm working at it. There we go. Is it showing through now?
It's still saying Jim Cliffe has started sharing screen sharing, but it hasn't actually shared anything yet. So.
Well, let me.
Well, it may just not want to work tonight, but we go. Well, we'll talk about it more next week anyway.
Yeah,
so.
I'll have I have an animation for it for next week, and we'll talk about the different ways we can look at it.
Yeah, and let's hope the weather next week's looking like it's going to be this week. So this. Thanks. There it is. Yeah, there you got it.
Okay, this is set for the evening of the 23rd at the time is 11 or 10:55 approximately.
Yeah, just before 11.
And there they are there, yeah.
We're 11. There is Virgo here and the other one.
Leo.
Leo, thank you. Momentary brain fart there. Anyway, Moon is right in between the two. I'll zoom in here. And you can see there is New Virginis right here. And as we increment the time, you can see the disk of the moon is gradually approaching it. And we should, in theory, well, it should have disappeared behind the limb, but
so it's behind the it's behind the moon
well
now.
Behind there. But anyway,
it just shows it's still there, yeah.
Yeah. By what this is 25 minutes after, it's going to be well into the disk. So
yeah, the official time on the IOTA site is 11, I think 14 or 15 our time, local time.
Okay, well there's 11:11 right there, so that would be about it.
Yeah.
Yeah.
That is approximately where you would see it.
Excellent.
Yeah.
Well, we'll have to see if we get any reports on Bill Weir was going to go try and see if he could see the moon tonight. So we'll see if he managed.
I tried just from my skylight here. But if you see behind my head, that's the predicted visibility. And the band that we're in, this green one, what it says is it's at the level that you have to see it first in a telescope to be able to
try and find it.
Prepare to see it.
Yeah. Yeah, it'll be better tomorrow.
The dark green is easy, and this green here is should be okay. We're in the third level. Anyway, I did not see it.
No. We'll see if he was able to. Well, certainly you needed somewhere where you could see pretty much to the western horizon. You needed to see right pretty much down, I think so.
Could you cheat by using a go-to mount?
There you go.
That's
if you could get it aligned in time. Yeah. Very good. Well, thank you for all the interesting things tonight. That was a great collection. And if there isn't anything further, well, shall we call it an evening?
Yep.
Thanks, I think we shall. Okay, thanks everyone, and thanks for joining us, Brendon.
Randy.
And, good luck with the quest to see the Annular.
Thank you. I'll share with
you.
Randy.
Yes.
Do you have the key?
Reg will have the key.
Yeah.
Who?
Reg.
Reg. Okay. Then I email him then. Okay. Thank you.
Fantastic.